Neat question here is n takes each positive integer value from 1 onwards. How many different values are obtained for the remainder when n squared is divided by n plus 4? So one way you could approach this problem is to do brute force and just try lots of n values until you seemingly don't get any more values, or you might convince yourself there's infinitely many. But we always want to try and solve problems not using brute force methods. I'm going to talk about how we can do it using an alternative method, because really we want to do a division. We want to do n squared divided by n plus 4. There's actually a way you can do this using polynomial division, which you tend to learn about in A level. So I'm not going to go via that approach. Instead, I'm going to think about how I can cancel down the top um, using the bottom. And what we can actually do, this is worth knowing this skill because it can be useful in lots of situations, is we can minus 16 from the top and add 16 to the top at the same time. And why would I do this? Because I'm going to try and write it as a difference of two squares. If I can get n plus 4 times n minus 4 at the top, like that is my first thought, then I can cancel out the n plus 4. So this becomes n squared minus 16 over n plus 4 plus 16 over n plus 4. And that's going to be a lot easier to deal with because I don't have n at the top as well. And then this is n plus 4, n minus 4. So you might not get that straight away. You might, maybe minus 4 from it. But then you see it doesn't quite work because that would be n plus 2, n minus 2. But once I get to here, actually these cancel. And the n minus 4 is, well, it's not um, necessarily the quotient because we don't know what's going to happen with this, but it is an integer part that comes out. So it's not going to have anything to do with the remainder. So this term is now what is going to decide the remainder. Now, just be very careful at this point about jumping into conclusions. We're not necessarily going to get 16 remainders. We need to investigate this, but the good news is now there's more of a systematic way of investigating it. Before we had n at the top as well, which just made it really awkward, but now I've just got n at the bottom of the number. And what I'm going to do is try different values out and see what remainders we get. So n starts with 1, that would be 16 divided by 5, which gives us 3 remainder 1. So we can get that one. Brilliant. And off we go. If n is 2, then it's 16 divided by 6. Takes us to 12. The remainder is going to be 4. 16 divided by 7. Get to 14. It's going to be a remainder of 2. And we just keep working through it. 16 divided by 8, actually, that goes into it entirely. We get 0. 16, if we have 5, 16 divided by 9, only one lot of 9, then remainder of 7. 16 divided by 10, remainder of 6. 16 divided by 11, remainder of 5. Then 4, 3, 2 again. And here 1. Right, I'm going to have to continue this table down here. Now if I go with 12, then again I get a remainder of 0. What happens if I go with 13? Then I'm doing 16 divided by a number bigger than it. Suddenly the remainder actually jumps to 16. And essentially, if it's greater or equal to 13, then I'm dividing by a number bigger than 16. I'm always going to get a remainder of 16. But you can see from this, then we've not got every remainder. We've not got a remainder of 8, for example. So I just need to now carefully add up how many I have. Okay, I'm actually just going to list them. So 0, 1, 2, 3. I can see all these as I go along. Some of them I've got twice. 4, 5, 6, 7. And then I jumped to 16. I didn't have anything between 8 and 15. So those are all the remainders that are possible. And that gives us 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is a tricky question, I think. Really interesting though, and I hope you enjoyed it.